So part 10 of the review for the final is going to be just things that I may not have said already, but that may be important. So I just want to go through whatever comes to mind that might be important for you. We talked about SI units, and SI units. You would need to know that we got kilograms for mass, meters for length, and seconds for time. I think everybody knows that. That's important. Everybody should know that. We talked about displacement, which I already mentioned on one of the videos. Displacement is the change in the position. That's the difference between the initial position, or rather, I'm sorry, the final position and the initial position. So the difference in position is displacement. So displacement is the difference in position. By the way, displacement is a vector quantity, whereas distance would be a scalar quantity. All right, so the difference between an object's initial position and final position, we talked about that. Some initial position, the object's here, moves to some final position here, and the difference between those two positions, we said, was the displacement. That is a vector quantity. Right, so in this case, the vector would be pointing in that direction. So with that idea of displacement, it is entirely possible to move a distance but not have any displacement. How can that happen? Suppose you're on a circle. And you start here, so let's say that's your starting position, and you're going to go around the complete circle and wind up back where you started from. So your final position is exactly the same position as your start. So anytime you have anything moving or covering distance, if you come right back to where you started from, your displacement will be zero because your initial and final positions are the same. We talked about free fall, and for free fall, there's an acceleration that's due to gravity. Later on, when we studied gravity, we called it little g, and that acceleration that's due to gravity near the surface of the Earth is 9.81 meters per second squared. It's important to know that. You shouldn't leave physics without remembering 9.81. That's the acceleration of an object in free fall near the Earth's surface. So anytime you have the Earth, you have some object close to the surface and against the fall, it's going to accelerate with 9.81 meters per second squared. That's the acceleration for anything, projectile motion. We talked about things in the air that are moving under the influence of gravity. That's your free fall acceleration. And speaking of acceleration is a change in velocity over change in time. You know that velocity is a vector quantity, so v is a vector. So therefore, acceleration is also a vector quantity. So acceleration has a magnitude and a direction. So velocity has a magnitude and a direction. Velocity is a vector. Acceleration is defined as the change in velocity over change in time. That too is a vector quantity. Newton's second law, F equals ma. Here's your acceleration. It's a vector. Therefore, force is a vector. The units of force, remember, are measured in something called a Newton. So if I ask you what's the SI unit for force, that would be your Newton. And the Newton is the SI. So this is the SI unit of force. We talked about Newton's laws. This is Newton's second law. Newton's first law is inertia. And you need to be able to state what inertia is. You need to be able to tell me that inertia is either the tendency of an object to resist change of motion, or inertia is the property whereby an object at rest stays at rest. An object in motion will stay in motion at constant velocity. Okay, until some net force acts on it to change the motion, to change the direction. Remember, anytime you have an object that's moving and it changes direction, some net force had to act on it to get it to do that. So this concept of net force is the sum of all forces. If you have two teams playing tug of war, like we just did recently when we had Battle of the Classes, if both teams, here's team A and here's team B, and they pull with equal force, the net force is going to be 0. Because you add up the forces. This is a force so many newtons in this direction, so many equal newtons in that direction. One's positive, one's negative. You add them all up, the net force is 0 because they cancel each other out. So if you're playing tug of war and you have equal and opposite forces, the net external force on the rope is going to be 0 because it's going to be a balanced system where they cancel each other out. We talked a little bit about work. Work, remember, is force times distance. In case there's an angle involved, where your force is this way and your displacement is this way, then work would be force times the distance times the cosine of the angle between the force and the distance. So positive work and negative work comes into play when we talk. Let's clear this image. So if you have a wagon, say, and somebody pulling the wagon this direction, so they're applying some force on the handle of the wagon, and the wagon is moving a displacement d. Doesn't matter whether there's an angle here or not. Notice that the component of the force is in the same, that's doing the work, would be this component of the force in this direction. This is F cos theta. So this component of force is in the same direction as the displacement, so that's positive work. If the force is in the opposite direction to displacement, you're going to have negative work. So if you have a kid pulling some kind of a toy across the floor, it's going to be an example of positive work because they're pulling it, it's moving in the same direction that the force is being applied. We talked about kinetic energy. Kinetic energy is 1/2 mass times velocity squared. So if you're given the mass, you're given a velocity, this is the formula you need to know in order to find and calculate the kinetic energy, and that will be in units called joules. Okay? This is a scalar quantity. Kinetic energy is not a vector. Kinetic energy is a scalar quantity. The reason it's a scalar quantity is because when you square the velocity, it doesn't have any particular direction. The mass doesn't have any direction. And so the square of the velocity is always a positive number, and it's just giving you an energy figure. So kinetic energy is going to be a scalar. Okay? I may be going over time, so let me just stop here and we'll continue picking up where we left off on the next video.